Once you deploy any machine learning model in production, the next most important activity in the entire machine learning pipeline is about model retraining activity. But now the question comes, what new data would be required for model retraining activity, right? Because in order to perform model retraining activity, we need new data. And in new data, we need observations plus ground truth, right? Because otherwise we won't be able to perform any model retraining activity. So obtaining ground truth data is very important. And in some domain, it would be available immediately. And in some domain, it would be available after a certain period of time. Take an example of recommendation system. So in this case, the actual outcome would be known immediately. Whether customer has taken any action against the recommendation or not. It would be known immediately to the organization. So similarly, for the ad clicks, the organization would be able to understand whether customer has clicked on that ad or not. In those scenarios, the ground truth would be available immediately. And on the other hand, it would be available after a certain period of time. So take an example of fraud detection, where the actual outcome or the ground truth would be only known after a thorough analysis done by the organization. And in this process, it normally takes 4 to 6 weeks of time. This is the prediction, the actual prediction produced by my machine learning model. And after a certain number of days or weeks, my ground truth would be available. Right? So take an example, this is 4 weeks. Right? So this time we call as lag. Right? So during your model retraining activity, we need to make sure that ground truth is available. And while calculating what new data you need to consider for any model retraining activity, you need to consider this lag. Now we will take one concrete example to understand how lag will help in finding out what new data would be required for retraining activity. Okay, so I'm just taking data for 8 days or probably for week time. So on day 1, we have received a message and it has generated a prediction. So I'm calling this as pred1. And the actual ground truth for this message would be known after 4 days. So the ground truth would be available on day 5. So I'm calling this as ground truth 1. Okay. So similarly for day 2, I'm calling this as pred2. And for this message, we would be getting prediction on day 6. We are calling this as ground truth 2. On 7, again, it would be pred3. And this would be ground truth 3. We have noticed that the performance of a model has been degraded. Model degradation started. Right? And we have decided that on day 7, we need to perform a retraining activity. And before performing any retraining activity, we first need to identify what new data would be required for the model retraining. Right? And as we can see that it has been triggered on day 7, and the lag for my business use case is 4 days. Right? Because that's what we have seen in this example. So now for calculating new data, what new data we need to consider? We need to consider the day on which my model retraining pipeline has been triggered, so which is on day 7, right? So which is day 7 minus the lag. So lag is 4 days, so which comes to day number 3. So which comes to this point. And from this diagram, we can clearly see that the ground truth for all the messages which we have received on day 3 would be available on day 7, right? So which is already known. So clearly we can see all the data which comes before day 3 as my training data, right? So here in this diagram, we can clearly see that it's between 1 and 3. And this we call as new data, right? So for the training pipeline, which would be triggered on day 7, it will consider all the messages which we have received between day 1 and day 3, for which all the observations along with ground truth are available for a model retraining activity, right? So in this way, we can calculate what new data would be required and how much data would be required for performing the model retraining activity. And again, that will depend upon what sort of algorithm you are using and whether between these 3 days you have collected sufficient amount of data or not. And that's the decision practitioner needs to make depending upon the business use case and depending upon the business domain they are in. But in some cases, the performance of the machine learning model will start degrading much before the availability of the ground truth. So in this example, say for example, on day 4, we have noticed that my machine learning model performance has been declined, right? And we need to trigger machine learning model retraining pipeline to fix the model degradation issue. But the main problem on day 4 is that we don't have the ground truth available. How we can trigger a model retraining pipeline? That's not possible. So in those scenarios, we need to consider different mitigation approach, right? And the mitigation approach which we normally take is about the subsampling, right? So which we call as subsampling, which is very widely used approach for handling this non-availability of the ground truth. So as a part of this activity, what we will do, we will take all the messages and the prediction which we have received between day 1 and day 3, and what we will do a manual labeling of those instances, right? And here we need to consider one more thing. While doing any manual relabeling activity, we need to consider all type of messages. We don't need to focus only on one particular type of messages. Take an example of fraud case, fraud detection problem. So we need to take all the messages for which my model is very much confident that this message would be categorized as fraud. So definitely we need to consider those messages where the probability score for my model is very high, right? So we'll take those data. At the same time, we will also consider all those messages where my model is not very much confident with about whether that message is fraud or not. So we'll also consider the non-fraud type of data, right? So in this way, we are making sure that we are not only doing a manual relabeling for all the messages where the model score is very high, right? But at the same time, we are also considering those messages where my model is not confident about the outcome. And now business domain expert will take all those messages and will provide a manual label against those transactions or those messages. Okay. So once we'll do a manual relabeling for all those subsamples, we'll feed those data in the model retailing pipeline, right? And depending upon the business domain and business use case, you need to decide how much labeling would be required. Because if you're doing a deep learning activity, then definitely you need to do a lots of relabeling activity. But if you're using some traditional machine learning algorithm, then probably doing less number of data would be okay. So depending upon the type of algorithm, depending upon the criticality, impact, business domain, you need to decide how much data would be sufficient for the manual relabeling activity. Okay. So that's the mitigation action we take for non-availability of the ground truth, right? We need to be very cautious about what we are doing as a part of manual relabeling activity and what sort of messages we are considering as a part of that activity. But you just need to make sure that whatever resampling you are taking from the whole lot, it should be the representation of the actual population traffic. Otherwise, this manual relabeling activity would be biased towards one particular type of messages or one particular type of group, right? So that sort of decision or action you need to take while doing the manual relabeling activity. Otherwise, it will create a problem and it will generate a bias outcome. Okay, so just to summarize, in this video we have seen two different approach to understand what new data would be required for the model retailing activity. And the first approach is based on whether the ground truth is available at the time of model retaining activity. And the second approach is to address the problem where the ground truth value is not available at the point of model retaining activity. And in that approach, we have seen how we can manually label ground truth on the random sample of data. That's it for now. I hope you'll find this video useful. And if you haven't subscribed to my YouTube channel, I request you to subscribe to it. And thanks for watching it.